Hello, and welcome to our ENCMP 100 competition entry. This is Kdan Hillier, and I'm here with Josh Fisher. We have made a Math 101 course assistant.
At first we couldn't think of anything to do for the contest. We're sitting in an ENCMP attempting to do our math homework. Wolfram's not working. We start thinking, is it possible for MATLAB to perform an integral? And that was the start of the project. We start with a simple integral calculator, as shown here. We had to use Google to make the integral work, as it isn't part of the ENCMP course. However, we finally made it work. In fact, it worked so well, we decided it might be too easy. So we played around with the new class topic, volumes of solid revolution. We knew how to do simple integrals, so we thought we should make a new file specifically for revolution integration, just for fun at this point. We used several different MATLAB help forums to find functions like sort and MATLAB function. Once we finished this code, however, we were already on a roll. There was a slight problem in MATLAB that it wouldn't calculate an integral as infinity due to its storage constraints, but we had to tell it explicitly to assume the value to be infinity once it suppressed a certain value. We used e to the power of 15. There's also a bug where it couldn't calculate a volume if the bounds were the same. It would give a volume of 0. This was quickly fixed by an if statement. Next came series. Our series code was probably the most fun to write, but it was also the most challenging. We've had so many tests to do for convergence, yet we had to use them in a specific order for MATLAB to do them. You can, however, follow the pattern each time to determine the convergence of a series. It all begins with the limit summons test, which determines if the limit of the series when approaching infinity is 0. If it doesn't, it's a divergent series. Otherwise, onto the ratio test. You got 3 options. The one where it continues is if the ratio test is inconclusive. If inconclusive, the script will continue by doing the integral test. It assumes the integral can perform the proper integral and calculates the integral. Unfortunately, simple series like 1 over n didn't work in this version of the code, which was fixed by a simple allocation. However, by this time we already had 3 solid codes that were functioning sufficiently. We decided to attempt to form one large code of the 3 and create a basic Math 101 course assistant. Once we integrated all of the codes together in one, we could work out the bugs. We worked out most of the bugs of each of the 3 programs by adding simple nitpicky things like making 1 over n divergent and using the pretty function to display everything in a manner that is simply easier to read. Without this function, our displays were crowded and hard to understand. However, now we are able to see brackets and fractions as if it were written on paper. Since we were constantly adding new units to the code, we recently added the capability for a Taylor-Maclaurin polynomial. While this is technically a Math 100 topic, we put it in anyways in the hopes to find a way to create a series out of these polynomials, working towards power series representation. While the contest is now over, we're still determined to update the code until it can perform series representation, with segmentation and everything involved. It's really interesting that these things are only possible with 300 lines of code.
I'm just going to perform some simple examples to give a demonstration of the code. First, I'll do the simple indefinite integral x to the power of 2. We just follow on-screen instructions that guides us on how to input this. As we know, the integral of this is x to the power of 3 over 3 plus c. This shows the integral and pretty functions in action because it gives the integral in a nice format rather than all in one line. Secondly, I will show the test convergence of a series. I will use 1 over n squared plus 1. So 1 over n to the power of 2 plus 1. The limit of this as approaches infinity is 0, so the program will proceed on to the ratio test. We will replace n with n plus 1, as is shown in the instruction, to the left of the input, and hit enter. Because the ratio test is inconclusive, the program will proceed to the integral test and prompt for a lower limit. 1 will work just fine here. As we can see, the series is convergent, and as we can tell from other mathematical methods, the series is convergent. This shows our code to work. We hope you find this useful and appreciate all the hard work we put into it. Thanks!